Okay, here we have the 2015 acid-base question. You can see it's another long question. It came up in question 9, so it was worth 50 marks as it was a full question. So they start off asking us just two nice little definitions. So what is an acid according to Arrhenius? So we know that an Arrhenius acid is a substance that dissociates in water to produce H+ ions. Okay. In contrast to that, then we've got a Bronsted-Lowry acid, which is a proton or a hydrogen ion donor. Okay, so nice couple of definitions just to get us started. Part B then asks us to define pH, and we know that our definition for pH is the equation that we use to calculate pH. So it's minus log to the base 10 of the hydrogen ion concentration. And don't forget those square brackets because they mean in moles per litre. Now it asks us for one limitation of the pH scale, and we actually have a couple of limitations here. So we know that the pH scale is only reliable for dilute solutions. Okay, and another limitation of the pH scale is that it's temperature dependent. So you have two options there for that answer. Now, part C, they ask us to graph the curve for the titration. Now, I have the graph here from the marking scheme. If you want me to show you a little video of how to draw that graph, or if you're not 100% sure, just send me a message and I'll be able to do up a little video for you. So we can see we've got a nice standard titration curve here. Now, so that's part C. Part D asks us to calculate the initial concentration of ethanoic acid, and they give us the Ka there. So we know that ethanoic acid, that's our CH3COOH, and you'll recognize that from the organic chapter, and you'll also recognize it from our vinegar titration. So in order to calculate the initial concentration of the ethanoic acid, we're going to use the initial pH of 3.3. So that is the pH of the ethanoic acid before sodium hydroxide is added to it. So we know that the pH is equal to 3.3, and we know that that is equal to minus the log to the base 10 of the hydrogen ion concentration. So what we're going to do is we're going to calculate this hydrogen ion concentration, and we're going to use that then to calculate our initial concentration. So I'm going to bring the minus across here, and that will give me log to the base 10 of the hydrogen ion concentration. So then I'll take the inverse of the log, so it's 10 to the minus 3.3 is equal to the hydrogen ion concentration, which is equal to 5.01187 by 10 to the minus 4 moles per litre. So that's my hydrogen ion concentration. Now, how do I use that to calculate the initial concentration of this whole molecule? Well, we know this is a weak acid. So we have this other formula here for the concentration of the hydrogen ions. So that is equal to the Ka, which we are told, multiplied by the Ma. So we're going to calculate the Ma using this equation, and the number, or the moles per litre of the hydrogen ion concentration, that we just calculated. So I've subbed that number in for my hydrogen ion concentration. I'm told in the question the Ka is 1.8 by 10 to the minus 5, and that is multiplied by the Ma. So let's get rid of that square root sign by squaring both sides. And we'll bring everything across to one side. minus 5 is equal to the molarity of my acid. So that's going to give me an answer of 0.014 moles per litre of my acid. So that's the initial concentration of the ethanoic acid. Now they ask us to use your graph to deduce the volume of sodium hydroxide solution required for neutralization. Okay, so we know neutralization occurs at a pH of 7. So what we're looking for is the point where the graph is at a pH of 7, and the marking scheme has brought it down to us, and we know that we have got a volume of 20 centimeters cubed for part 2. Okay, part E then asks us what indicator would be used to detect the endpoint of the titration. So we have spoken about 3 indicators in our studies. We have learned about methyl orange, and we know methyl orange has a range of 5 to 3, and that means that it changes colour between 5 and 3. We've had a look at litmus, which we know has a range of 5 to 8, so it has quite a wide range, but it's less reliable. And we know that phenolphthalein has a range between 8 and 10. No, I'm not going to write the whole name for phenolphthalein. So in terms of selecting an indicator, we need an indicator that is going to change colour and that its range corresponds with the steep part of the graph. So here's our steep part of the graph, and we really only got one option that we're going to choose. We are going to choose phenolphthalein. So our indicator, let's just write that there, our indicator is going to be phenolphthalein. And how do we explain our answer? Well, its range is 8 to 10, which corresponds with the steep part of the graph. Okay, so that is the 2015 question. As I said, if you have any questions about this graph in particular, send me an email, or if you're not happy with how the indicator selection works, just send me a message and I'll get back to you.